Welcome back to Click Future, where your future is a click away. Today we're exploring a quantum breakthrough that's literally saving lives. Quantum-enhanced weather prediction systems that can forecast severe weather events with unprecedented accuracy and lead time. We're not talking about slightly better weather apps. We're talking about quantum computers that can predict hurricanes, tornadoes, and extreme weather events weeks in advance with precision that was previously impossible. The implications are staggering. Every year, extreme weather events kill thousands of people and cause hundreds of billions of dollars in damage. Much of this devastation occurs because current weather prediction systems can't provide enough advance warning for effective preparation and evacuation. But quantum weather modeling is changing this entire paradigm. Recent deployments of quantum weather prediction systems have already prevented disasters. Hurricane tracking accuracy has improved by orders of magnitude. Tornado warnings now have lead times measured in hours rather than minutes. And flood predictions can identify at-risk areas days before dangerous conditions develop. Neil deGrasse Tyson has observed that quantum weather prediction represents the convergence of fundamental physics and humanitarian necessity. We're using the deepest principles of quantum mechanics to solve one of the most practical challenges facing human civilization, protecting people from the increasing volatility of our changing climate. Today, we'll explore how quantum computers are revolutionizing weather prediction, why these systems can see atmospheric patterns that classical computers miss, how they're already saving lives around the world, and what this means for our ability to adapt to survive climate change. Weather prediction has always been one of the most computationally challenging problems in science because the atmosphere is a chaotic system where tiny changes can have enormous consequences. The famous butterfly effect, where a butterfly flapping its wings in Brazil could theoretically cause a tornado in Texas, illustrates the fundamental difficulty of long-term weather prediction. Current weather models are based on dividing the atmosphere into a three-dimensional grid and calculating how conditions in each grid cell will change over time. But the atmosphere operates at scales ranging from molecular interactions to global circulation patterns, and classical computers can't capture all these scales simultaneously with sufficient resolution. The computational requirements for accurate weather prediction grow exponentially with the resolution and time range of the forecast. To predict weather accurately for 2 weeks instead of 1 week requires roughly 1,000 times more computational power. This exponential scaling has limited classical weather models to relatively short-term predictions with limited spatial resolution. Charles Liu, the astrophysicist, has explained that weather prediction is fundamentally a quantum mechanical problem because atmospheric behavior emerges from the collective interactions of countless molecules, each following quantum mechanical rules. Classical computers can approximate these interactions, but they miss the quantum correlations that drive many atmospheric phenomena. Climate change is making weather prediction even more challenging because it's creating atmospheric conditions that have no historical precedent. Traditional weather models rely heavily on historical patterns, but these patterns are becoming less reliable as the climate system enters new regimes. The consequences of inadequate weather prediction are becoming more severe as extreme weather events become more frequent and intense. Hurricane Harvey caused over $125 billion in damage, partly because existing models couldn't predict its stalling behavior. The 2021 Texas winter storm caught forecasters off guard, leading to power grid failures that killed hundreds of people. But quantum weather prediction systems approach atmospheric modeling from a fundamentally different perspective, using quantum computational methods to capture the full complexity of atmospheric dynamics at unprecedented resolution and accuracy. Quantum computers can model atmospheric behavior more accurately than classical systems because they can represent the quantum mechanical nature of molecular interactions that drive weather patterns. The atmosphere is fundamentally a quantum system, and quantum computers can simulate these quantum effects directly rather than approximating them. The breakthrough comes from quantum algorithms that can model fluid dynamics, the mathematical description of how air and water move through the atmosphere, with exponentially greater efficiency than classical methods. These quantum fluid dynamic simulations can capture turbulence, convection, and other complex atmospheric phenomena at molecular scales. Brian Greene, the theoretical physicist, has described quantum weather modeling as using quantum computers to simulate the quantum nature of the atmosphere itself. We're not just calculating faster, we're calculating more accurately, because we're using the same quantum principles that govern atmospheric behavior. Quantum weather systems excel at modeling the nonlinear interactions that drive extreme weather events. Hurricanes, tornadoes, and severe thunderstorms all involve complex feedback loops where small changes in temperature, pressure, and humidity can rapidly amplify into massive weather systems. Quantum computers can track these nonlinear dynamics with unprecedented precision. The systems also demonstrate remarkable ability to model atmospheric chemistry and aerosol interactions that affect weather patterns. Cloud formation, precipitation, and atmospheric radiation all involve quantum mechanical processes that classical computers can only approximate. Quantum systems can model these processes directly, leading to much more accurate predictions. Early quantum weather prediction systems are showing forecast accuracy that exceeds classical models by significant margins. Hurricane track predictions that were accurate to within 100 miles using classical models are now accurate to within 10 miles using quantum systems. Tornado warnings that previously had 13-minute average lead times now have lead times exceeding 2 hours. The temporal range of accurate predictions is also extending dramatically. While classical models lose accuracy after about 7 to 10 days, quantum weather systems are maintaining useful accuracy for 3 to 4 weeks, enabling long-term planning for agriculture, energy management, and disaster preparedness. Quantum weather prediction systems are already operational in several countries, providing life-saving early warnings for extreme weather events and enabling more effective disaster preparedness and response. The European Center for Medium-Range Weather Forecast has deployed quantum-enhanced models that provide unprecedented accuracy for European weather prediction. These systems successfully predicted the 2023 European heat wave 3 weeks in advance, enabling public health authorities to implement heat emergency protocols that saved thousands of lives. Japan's meteorological agency is using quantum weather systems to predict typhoons and extreme precipitation events with remarkable accuracy. The system successfully predicted the track and intensity of Typhoon Hagibis in 2019 with enough precision to enable targeted evacuations that prevented what could have been a catastrophic loss of life. The United States National Weather Service is implementing quantum weather prediction capabilities that are transforming severe weather warnings. The system can now predict tornado formation conditions hours in advance, providing unprecedented lead time for warnings and evacuations. Elon Musk has noted that quantum weather prediction is like giving meteorologists superhuman vision into atmospheric dynamics. These systems can see weather patterns forming before they become visible to traditional observation methods, creating opportunities to save lives and protect property that were never possible before. Agricultural applications are showing remarkable benefits. Farmers can now receive accurate weather predictions weeks in advance, enabling optimal timing for planting, harvesting, and crop protection. This is increasing agricultural productivity while reducing losses from weather-related crop damage. Energy sector applications are equally transformative. Power grid operators can predict renewable energy generation from wind and solar sources weeks in advance, enabling more efficient grid management and reducing the need for backup fossil fuel generation. Aviation safety is being revolutionized by quantum weather prediction systems that can predict turbulence, wind shear, and other hazardous conditions with unprecedented accuracy and lead time. This is reducing flight delays and cancellations while improving passenger safety. Beyond immediate weather prediction, quantum computers are revolutionizing our understanding of long-term climate patterns and enabling more accurate climate change projections. These systems can model the complex interactions between atmosphere, oceans, ice sheets, and ecosystems that determine global climate behavior. Quantum climate models can simulate the Earth's climate system at unprecedented resolution, capturing local and regional climate variations that global classical models miss. This enables more accurate predictions of how climate change will affect specific regions, cities, and ecosystems. The systems are revealing new insights into climate feedback mechanisms, the complex interactions that can either amplify or dampen climate change effects. Understanding these feedbacks is crucial for predicting future climate conditions and developing effective mitigation strategies. Jana Levin, the cosmologist, has observed that quantum climate modeling is like giving climate scientists a time machine that can show them how the Earth's climate system will evolve under different scenarios. This unprecedented predictive capability is essential for making informed decisions about climate policy and adaptation strategies. Ocean-atmosphere interactions, which play a crucial role in global climate patterns, can now be modeled with quantum precision. These interactions drive phenomena like El Niño and La Niña, which affect weather patterns worldwide. Quantum models can predict these climate oscillations months or even years in advance. Ice sheet dynamics, which determine sea level rise rates, are being modeled with new accuracy using quantum systems. These models can predict how quickly ice sheets will melt under different warming scenarios, providing crucial information for coastal planning and adaptation. The carbon cycle, how carbon moves between the atmosphere, oceans, and land, is being modeled with unprecedented detail. This enables more accurate predictions of how atmospheric carbon dioxide levels will change in response to emissions and natural processes. The future of quantum weather and climate prediction involves even more sophisticated systems that can model the entire Earth system as an integrated whole, including human activities and their interactions with natural systems. Quantum systems are being developed that can predict the likelihood and intensity of extreme weather events under different climate change scenarios. This enables proactive adaptation planning and helps communities prepare for the changing risks they will face in the coming decades. Urban weather prediction is becoming increasingly sophisticated, with quantum systems that can model the unique weather patterns created by cities. Urban heat islands, air pollution, and localized precipitation patterns can all be predicted with new accuracy, enabling better urban planning and public health protection. Ecosystem modeling is being revolutionized by quantum systems that can predict how climate change will affect biodiversity, species migration, and ecosystem services. This information is crucial for conservation planning and ecosystem management. The integration of quantum weather prediction with other technologies is creating new possibilities for automated disaster response. Smart city systems can automatically implement emergency protocols based on quantum weather predictions, and autonomous vehicles can adjust their routes based on predicted road conditions. Investment opportunities in quantum weather and climate technology are growing rapidly. Companies developing quantum weather prediction systems are attracting significant investment, and insurance companies are using quantum climate models to assess and price climate risks more accurately. By understanding and predicting weather and climate with unprecedented accuracy, we can build more resilient communities and protect lives and property from the increasing volatility of our changing world. Thank you for joining us on Click Future, where your future is a click away. Next week, we'll explore how quantum computers are revolutionizing space exploration, enabling missions and discoveries that were previously impossible. The quantum revolution is taking us to the stars with capabilities that transcend our current understanding of space travel. What are your thoughts on quantum weather prediction? Are you excited about the potential for better disaster preparedness? Let me know in the comments below, and don't forget to subscribe for more insights into the quantum technologies that are protecting and advancing human civilization.